Good afternoon, everyone, and welcome to our last session for this course, Statistics. So we have 2 hours today. So initial 1 hour, what I will do, I will go through the week 12 tutorial class. We have two questions are remaining. Question number, exercise 3 and 4. We'll try to cover that one as a part of tutorial. And then last 1 hour, I will just take your questions from anywhere. One by one, you can ask. For those who wish to leave early, they can leave after 1 hour. That is not a problem. So you can put your, you can mark your attendance in the chat box. I have given you I've already discussed about the instruction for the exams. And I have already provided you the template for the answer sheets. So go and download it from under the announcement. There will be a communication and regarding the exam instruction and the answer sheet template. So download it and keep it safe in your system. Okay. You can mark your attendance in the chat box and then we can start. Week 12 tutorial class. I will try to cover exercise 3 and 4. Excel is used to generate the following. I think we have. Can we jump to the Excel sheet there? Where is the Excel sheet? Let me open that. This is not the Excel sheet. Exercise number 3. No, not this one. Where is that one? Big 12 tutorial exercise. I'm just looking at the Excel sheet where we have data on the exercise 3 and 4. Yeah, 3 is here and the exercise 4, right hands and left hands. Okay. Now I could share with you. Okay, this is exercise number 3. Consider the following list of data values, X and Y, and Excel is used to generate the following. If you see the output, which is given to you, what do you think? Which one is independent and which one is dependent variable? You could see X is on the horizontal axis, whereas Y is on the vertical axis. If you look at the, which one? Scattered plot. So we are assuming accordingly we can think about in this particular exercise, y is treated as a dependent variable and x is as a independent variable. So try to analyze this one using the scattered plot. Select. I hope you guys are able to see the Excel sheet, or maybe I can share once again. Yeah. So you have the data for x and y. Select these two columns and insert. You have over here scattered plot. Select scattered. Okay, so you could see here the scattered plot. The output is same as which is there in this exercise. Scattered plots, it says it shows something like not the downward trend, it's a kind of increasing trend. So slope, you can observe and make a kind of observation from this scattered plot that there is a positive correlation between x and y, and the slope of this relationship is positive. So positive correlation between x and y. But we are more interested in the regression output. So I'm just deleting this one now. Okay. So we are interested in the summary output of the regression statistics. So go to data, data analysis, select regression. So in this case, y is the dependent variable. So this is y input range, x input range is x. I have selected labels. Confidence interval, you look at here in this output, lower 95, upper 95. So yes, 95% they have selected. Output here, I wanted to see the regression output over here in the same sheet. Yes, there is a question based on the residual plot. If you could see the exercise number 3I, based on the residual plot, is the regression equation is a good model. We'll do the residual plot analysis later on, but you see there is a clearly a kind of option here for the residual plot. So if you click this one, it will give you the residual outputs also. Okay, let it be. We'll do the analysis at the last because it's a part of I, and then press OK. What is there in front of you? Regression analysis. Just click here. You see some of the, you want, if suppose wanted to have a kind of more clarity, just over here, double arrow, just click twice. It will spread. And then you have the residual plot. We'll look at the residual plot at the last, and before that, we'll go through each and every sum from A to I. So this is the regression output in front of you, and that will be only given to you in the exam. And then you are supposed to ask, to analyze, you're supposed to answer for the different questions, sub question for this exercise. So I will go through one by one. Part A. From the scattered plot, what is the relationship between x and y? What we have seen, the scatter plot, which on the screen we have seen, and we said that with the observation of this scatter plot, it says that there is a positive relationship between x and y. That is the part A. Part B, exercise 3, part B. What is the linear correlation coefficient R for the sample data? So where is the linear coefficient, correlation coefficient R? So multiple R is the same as the linear correlation coefficient. And what is the value? 0.99997. So it's almost 1, right? If you could change it into the 2 decimal, let's see, let me see that. No, it's increasing. Yeah, over here, if there is an option, if you do the same thing for remaining, yeah, you see that it's converting, it's converging towards zero point 0.1. Keep that one in mind. That's what this output is. Now it looks like the same one which was given to you. So it was easy to look at the value of r, that is a multiple r 1.0. But what is important here? How to interpret this value. So how to interpret this value? What R does? R tells how strong the linear relationship is. In the scattered plot, somehow we observe that there is a positive slope between x and y. So there is a positive relationship between x and y variables. Somehow we understood that from the scattered plot, but scattered plot doesn't give you the any idea about how strong it is. Is it a moderate level? Is it a strong level? Is it low level? Is there no relationship between? So it doesn't indicate. The scatter plot doesn't give you any idea about the strength of relationship. And for that, what we have R, correlation coefficient, that talks about the strength of the relationship between the variables. In this case, we have two variables, x and y. So how these two variables are related? What is the strength of relationship? Since it is 1.0, we can say it is a very strong, very strong relationship. What is the actual interpretation? Very strong relationship means there is a slight changes in x, value of x, the equal amount will be changed in y. So it's a very strong relationship. That's why we have seen that slope is almost look like 45 degree. Slope is 1. 1045 degree is 1. That's why you see in the observation the slope of this curve is uh, at 45 degree. That gives a kind of indication that it's a perfectly strong relationship. So you understood the part B. What is the linear correlation coefficient and how to interpret this one? Interpretation is it's a very strong, very strong. But we have seen the scale, different scale of R. It is there on my slide. So if something is 0.5 to zero point 0.8 or zero point 0.8 to 1.0, we have the different scales: strong, moderate, low. And what about multiple r if in the case of 0? If r value is 0, that means there is a no relationship between the variables. Is that clear? Let me see if there any doubt. You can write in the chat box. Otherwise, I will continue. Please mark your attendance for your final class and go through your all overall attendance. And if you think that is there any mistake, please let me know, because I have all the records of your attendance. So I can quickly go through that one. And in case of any issues, I will update you. No problem. So I was here. Part B, we understood the interpretation of R. Now part C. Okay, we have an interpretation of R square later on. No worries. Part C is what is the regression equation for the sample data? They're just asking what is the regression equation. They're not asking for the validity of this equation. They're just asking, can you interpret? Can you make a equation for the regression? Why? So for the part C, if you could remember, I can write here instead of board. I can write here. What is the what is the template for writing the regression equation? You have to write in this way: dependent variable y equal to b naught. I'm writing here b naught. B0 is bo. B naught plus b1, and then as a function of x. Remember, over here in this case it is x and y. X and y can take any of the values. Maybe y will be revenue. You need to read the question. Are they talking about the relationship between revenue and market share? X could be market share and y could be revenue or firm performance. So blindly writing x and y will not give you the good right amount of marks. So don't be blind in terms of writing x and y. These are the examples where they have used x and y. That's why I'm using x and y. But x can take any value, y can take any values. So read the question properly while writing the answer. Okay. So so this is the standard equation for writing the regression line. Part C I'm talking about. So you have to find out what is B0 and what is B1. And that is there in the regression statistics. So you see the intercept here, intercept value. This is known as B0. I'm writing here, this is known as B0. Whereas the X is your, X is your B1. And these are the values actually which we are interested in. These are the values. So just take all these values and write down y equal to, I'm writing the regression equation for the sample data. This sample data, I'm writing the regression equation. So B0 we got 4 point. If there are more, try to make it in 2 decimal or 3 decimal maximum. So 4.0056. So we can make 006. 006. 2 to 3. Make sense? 0056 so 006. Yeah, that is B0 plus. Since over here you see the coefficient of x 0.3453 having a positive sign, that's why I'm writing here positive plus. In case of negative here, sign here, you must write negative. So plus B1. B1 is 0.3453. So 345 will be fine. 345. So 0.345. 2 to 3 decimal point will be fine. No need to write a complete one. And into x, capital X. So x and y can take any values. Suppose x could be in example performance. Performance will be example like something 3.44 plus 1.46. I'm just making an assumption. Or maybe over here performance, any of the firm performance will be dependent on the market share. So I can write market share. So in that case, 3.44 is the value of B0. 1.46 is the value of B1. So instead of X, it will be written here market share. If suppose you have more than one variable, like X1 over here Z. So one more variable is there. So you need to integrate that one here itself in this equation itself. So suppose one more variable, Suppose that sign will be minus 2.76, any arbitrary. Your performance will be dependent on market share, or maybe in terms of research and development, R&D, how much in more R&D, more performance. I'm just assuming that in the business term. So then if there is a two independent variable, you will be having X as a market share, Y as a R&D expense. And then corresponding value will be 1.46 will be given here, and minus 2.76 value will be given here in this place. And intercept value will be 3.44. Then you have to write this equation. And this will be your right regression equation. So remember, yeah.
So if the Z value is like 2.76, it'll be plus 2.76. Is that right?
Once again,
if the Z value it's 2.76, it's not minus, so would that be plus? Is that right?
Yes, yes. So I'm assuming here, I'm writing here minus 2.76. Then only I took it as a minus 2.76. But in case if that value is positive here, no sign means positive sign, then I will consider this one as a positive one. That's why I was keep telling you that sign is very important. In this case, it will be plus then.
Okay, thank you.
Or maybe sometimes if X value is negative here, instead of this one maybe negative, so you have to put X over here negative. So it's just like you have to look at the same sign, and then you have to put it in the performance. So that is the hang on, yeah. So you understood the importance of having more than one variable. Keep that one in mind. So look at nicely. There will be only one constant value, that is intercept. Only one constant. But more than one variable, two variable, even three variables. So you have to put everything in the regression line. Part D. Given an interpretation of the value of the slope, okay, given an interpretation of the value of the slope that was given in C. So this is the part C, this is the equation, and they're asking for the interpretation of value of the slope. Where is the slope? This value is the slope. As I said, V naught value is the slope of your line. This is known as the slope of your line. You wanted to see, is that right or not? Quickly, I will show you. I'm taking you through the scattered plot. Taking you through the scattered plot. This is your scattered plot. Right click. You could see right click at any of the point here. You have option of add trend line. So if you click that, now you saw the slope. But what is the equation? So over here, right side, just scroll, right side, display equation on chart. You see that clicking this one, displaying the equation. Close. Did we get the same equation here over here? Yes. It is just other way around. I put in my equation B naught first, but over here they put the B1 first into X. So 0.345 into X plus 4.0056. That is 4.006. So I was telling you that what is the slope here? So this value in the Excel sheet, 0.345. This is your slope, which is attached with equation X. So question is, how could you interpret this one? I'm removing this one. We wanted to have an interpretation of slope. So you need to provide the interpretation for B1. How you will write the interpretation for B1? Anyone? Anyone? What will be your interpretation for the slope T1? Look at the equation. If 1 unit, if there is a 1 unit of increase in x, then by what amount y will increase?
0.345.
Exactly. So this is a simple interpretation. You have to write in the word the same thing, which I'm writing here now. For each unit increase in x, I'm writing here for you. For each unit increase in the value of x, comma, y will increase because the sign is positive. Slope sign is here positive. That's why I'm writing y will increase by increase with how many units? 0.345 units. This will be the interpretation here in the current case. Okay. This is the for each unit increase in value of x, comma, y will increase with the slope amount. But in case of minus 3.45, we will write for each unit of increase of x, y will decrease by if the slope value is negative. But over here it is positive, that's why we are using increase. X will increase, y, and see the trend. Slope, it's a positive. So 1 will increase, x will increase, y will also increase. And that is the interpretation over here. Where is that? Over here, x and y. 1 more unit increase, y is also increasing. 3 unit increasing in x, y is also increasing. But at the same amount? No. For each unit of x, 4 to 5, y is increasing by how much? It's 0.73 or 0.34 into 1. Yeah. So you have to understand this one. And what is your constant term? This is the constant term. This one. This line where it cuts the x-axis, y-axis. If you extrapolate this line at the backward, you'll see this line will cut where I'm pointing out using the mouse. If you extrapolate backward, somewhere here, this line cuts y-axis. And what is the value of that? That value is 4.5005. That is the B naught. So that is 4 points. So this line, if you extrapolate at the back here, back side, at 4.00056, it will cut the y-axis. So this value is B naught. This is your intercept, y-intercept. Whereas this is the slope. If you this is line, there is a slope, so that slope is 0.3453. Then part E. What is the 95% confidence interval for the unknown population slope parameter? We have calculated this one several times manually, but from this Excel output, you can clearly point it out. You can clearly identify what is the range, what is the 95% confidence interval range. So where it is there, lower 95, and you see here, the last two column is the same. It's a kind of repetition, but look at both are the same thing. So over here is lower, and over here is upper. Because the CI estimation, we are trying to see, remember, x bar minus e, x bar plus e. So lower, upper. So you have the output in front of you, but again, which interval you will take? There are two values, like one for the intercept and one for the B naught for the x. You have these two values and these two values. Which one you will take? What is the 95 confidence interval for the unknown population slope parameter? Now you know which one is the slope. And even if slope is not mentioned, you have to consider the one which is for the variable, because the intercept is a constant. We should never consider that interval. We should only consider the slope or the variable corresponding, which is the corresponding to the variable. So in this case, if you could look at the 2-digit, because all the answers I'm asking for the, so what is the interval came? What interval came? Your interval CI estimation is, what interval we got? It lies between 0.34 comma 0.35. This is the range. Lower and upper at 95% means alpha value is 0.05. Alpha is 0. In this case, you understood that since it is 95, 99 alpha value is 0.01. But for 95, you keep always in mind, in this case, alpha is 0.05 without any doubt.
Sir,
Yes.
if the questions are like, for example, if the things like for CI interval, if it's given in 3 or 4 decimals, so we have to convert it into 2 decimal.
Yes, all the answers I'm asking you in the exam only in 2-digit. Point, digit 1, digit 2, all the answers.
And if there is any answer, for example, like 0.0003, so for
Consider
that
0.00.
okay.
But probably not much. But in that case, if suppose the question is like p-value, and if that comes 0.000045, just
Yeah.
consider 0.00. 2-digit in the best manner.
Okay.
Make sense? Yeah?
Yeah.
Thanks for asking. This is again a good question, like to what digit? Clearly, each question will be mentioned, and I made it uniform for my simplicity also, because I need to check your answers it in a clear manner, clear with the clarity. So you will give me the clarity in your answer. For me, it will be the easy. So just try to
Yeah.
make it. But certain if even if you do certain amount of the mistakes, that I will consider. Don't worry. It should not vary much. I mean, so,
And if there, like, for example, margin of error and confidence interval. So last question is confidence interval. So we should round at the last question, right?
yes, the final one, not in between.
Okay.
Yeah.
Yeah. Okay.
Yeah.
Thank you.
So where we were, okay. So what is the 95% confidence interval for the unknown population slope parameter? So if you're writing this confidence interval, try to write in the sentence also. You provide and interpretation. Try to give the interpretation. You remember, we are 95% confident that the population part parameter will lies in this interval. So that keep that one in mind. Try to give it should reflect your learning as well. Keeping the exam apart, you have done very hard work and all. So you should try to have a kind of reflection on the paper. Bring it out. Question number F now. Based on this interval, is there a linear relationship between X and Y? Explain why or why not. But the question is, this question is in relation with part E. Based on the 95% confidence interval. What do you think? How to proceed with that one? In the slide, somewhere I mentioned that you need to look at the zero. Where is the zero? Does the zero, this is the interval for the slope, right? This is the interval for the slope. Slope lies between 0.34, 0.35. Does zero lies in between? No. If zero doesn't lies means there is a relationship. In order to have the relationship between x and y, the zero should not come in this interval. What is zero actually? If the confidence interval contains zero, what exactly that meaning? That means that there is a chances of being slope as a zero. The moment the slope will be zero, v0, v1 value will be zero, there is no relationship. Since this interval over here, 0.345 and 0.345 and 3.4, right? Since this interval, what is the question here? Based this interval, is there a linear relationship between yes or x and y? You have to write, since zero doesn't contain in this interval, you should reject null hypothesis. Null hypothesis, what is the null hypothesis? There is no relationship. What is the alternative hypothesis? There is a relationship. Are you able to understand or not? I should take you to the slide there. In case of this, you should keep in mind this one. Over here. These assumptions are very, very important. We are talking about the slope b1 here. So if slope is zero, means there is no relationship. In order to exist a relationship between x and y, there must be any value apart from zero, any value of b. In that case, there will be a linear relationship. So since zero does it not lies, in our case we have seen 0.34 slope range, right? Confidence, we are confidence 95% confidently we can say that slope lies in the interval 0.34, 0.35. So with that interval, with that confidence, there is no chances of having a slope value zero. So if there is a slope value is not zero means what? There is a relationship. So if, see the second one, if zero doesn't lie in this interval, we do reject null hypothesis. And what is our null hypothesis? There is no relationship. Finally, it implies that there is a relationship. So we can say for the part F, based on this interval, there is a linear relationship between x and y. Why? Because zero does not lie in the interval, confidence interval. So we reject null hypothesis. And there is a linear relationship between these two variable action. Make sense? Does that make sense to you all?
Yes.
Yes? Going back to Excel. See it here. Okay. Part G. What is the value of the coefficient of determination? So the moment you see the word coefficient of determination, actually they are talking about R square. And we know the R square is a variable or variance. If you just multiply 2 times R, it will give you the R square value. So what is there the R square value here? In this case, you could see what R square value is coming. It's 1. Again, But that is not important here. You will not be allocated marks for just saying that R square value is, or the coefficient of determination is 1.0. You will not be allocated any marks just for saying that it is 1.0. We need an interpretation. Without interpretation, there will be no marks. So how to interpret this one? As I said, the R square value gives you the indication regarding the variance, the percentage of variance explained by the explanatory variable. So the percentage of variance explained in Y by the explanatory variable X. How much is the percent? In this case, clearly 1 means 100%. So what you can rewrite or interpret in a manner that 100% of the variance in Y is explained by the explanatory variable X. If R square value is 0.9500, we will write the 95% in the variance in Y will be or is explained by explanatory variable X. Or imagine the case of, the market share and the performance. Suppose performance is Y and market share is X variable. And there is a R square value is suppose 0.65. How we will interpret this value? So in that case, 65% of the variance in performance is explained by explanatory variable market share, which is market share. So you have to bound your answer in terms of what independent and what dependent variable is given to you. Surely in the exam, it won't be X and Y, something else. Be careful in that. But by this way, we understood how to make an interpretation for the coefficient of determination. You could look at on the slide also, like I think one of the slide, it is clearly stated that. Okay, yeah, this one. The value of R square is the proportion of the variance in Y, variance in dependent variable, explained by independent variable in the linear relationship between X and Y. So R square is the proportion of the total variance that can be explained. We conclude that in this case, 100% of the total variance in Y variable can be explained by the X variable. So if suppose 95% is explained by this variable X, the remaining 5% might be explained by some other factors or the controlling variables that we are not known, that is unknown to you in this case. So what do you think? In this case, X is a good predictor of Y or not? 100% is changes in X in Y is explained by X, means it's a very strong predictor. It's very, very strong because it's 100%. So in the case of 100%, there is no other predictor, I mean to say. So you can logically argue or write one more sentence is that thus X is a very strong predictor for the Y. Or maybe the market share is a very strong predictor for analyzing firm performance. Think on those lines. Hope that makes sense to you.
Wait, sir. So the conclusion will just be we can conclude that 100% of the variations in table Y is caused by X. That's it.
Exactly. But you
Okay.
can rewrite what I said. If you understood better, you
Yeah.
can write, thus we can say that X is a strong predictor.
Okay. Okay. Got it. Thank you.
Take it out. You learn something, write down.
Yeah. Okay. Thank you.
Okay, now we have part H. What is the predicted Y if X is 8.52? For that, I'm writing here. Suppose X value, they are saying that finding Y in case of X equal to, so I'm just writing the value of X value equal to, given how much? 8.52. So what is the value of Y? If in the case of, so using Excel I'm showing you, you can do it manually. So what it shows that, so according to me, Y will be equal to, as per the formula, 4.006. So I just click here in this cell plus equation says B1 plus B1 over here. So this is 345. I'm clicking here, E90. And then into, you're saying the X value 8.52. So I'm selecting K2. And then I will, it's better to, put these two together. Always I will suggest you. If you're doing the Excel sheet, but for the exam, you will not do. Yeah. This value is the predicted value of, the question will be 2-digit. Yes, this is the predicted value of Y. This is the predicted value of Y when X equal to 8.52. Full stop, your answer. But in this question, there are other subpart. So probably this question will be 2 or 3 marks, like 1 marks for just calculating Y value. If you have written 6.95, you will receive 1 mark. And that, suppose another mark will be for the argument. What is the other question here? Is this a valid prediction? Explain why or not. This question is again very important. Although something is in front of you in terms of regression output, regression model, everything. But are you confident at 95% that this model is reliable? Can we say that on this basis we can take a major decision because the output comes like this? How could you say that? That's what here the question is. Is this a valid prediction for Y in terms of measuring, in terms of when measuring in terms of X? The question is that a valid prediction? Is that means, is this model or is this regression? Model means regression line, which we have put. This is the regression line. The question is this regression line is a valid? Is this model or is this regression line? All these are the same meaning. Is the regression line is reliable or valid? Is the model is valid or reliable? Both are same. Although we have calculated the value of Y, but are we confident? 95% confidence level, can we say that this model is reliable and blindly people should follow this model? So whenever the X value will be given, Y will give this value. We are 95% confidence. Can we ask this question? So for that, we need to see another value. Just to check, is this model is reliable or not reliable? Or this model is valid or not valid? Or is this prediction is valid or not valid? So irrespective of whatever the question is, like All these are the synonymously can be changed. It can be used. What value you have to look at for that answer? The very important term over here is significance F. Significant F value. Level of significance. I mean to say the significance F value. This is also known as the P value. Just let me put you all mute. Okay. I was talking about to check this model is reliable or valid or not, you need to look at the significance F value. This value is also known as P value. We have seen the right probability value. P value. This is actually the same as the P value. And remember the P value greater than alpha, P value less than alpha, we have a decision regarding H naught, go or should not go. So, there is a confusion here. It seems like the P value is, don't consider this one as a P value as a 6.17, because you see at the last, it is using the word E. E is exponential. I think exponential value is something 2.76 or something. And then raised to E is minus 22, means E raised to the power 22. If something raised to the power 22 means it will go at denominator. And it will make everything on the numerator very close to 0. I mean 1 by or 6 by, imagine 6 by 10 millions. What you will get? 0.0000000. So always remember, it looks like something for value, significant value in terms of like, but try to look at the carefully when you are using the Excel sheet. You need to carefully read this one, these lines. It's exponential E 20 minus 22. So minus 22 will go down denominator, then it will make the numerator very, very minimal and it will be very close to 0. You wanted to see what exactly this meaning? You see on the top, or maybe it's very, very small one, 22 times. If you just play with this one, now it started coming. So it will be close to 0, I mean to say. Okay, how to check it? It will be close to 0. There is one smart way. Any idea? Anyone? If you don't believe this is close to 0, is there any way to check this one? Anyone? Let me see. Can you quickly analyze any alternative way to check this one is 0 or not? Okay, suppose I'm saying this is 99 or 0.9, suppose 0.9. If we will subtract this one from 1 minus 0.99, it will give you a 0.01. If I'm assuming that 6.17 E minus 22 is 0, if I will subtract with 1, how much I will get then? 1 minus, put it equal to 1 minus, now I'm subtracting, I'm saying that this part is 0. So 1 minus this. 1 minus 0, how much it will be?
1.
See, it's coming 1. So that is the confirmation. That is the confirmation that this value is. You see, it is coming. Make sense? So, but anyway, for you in this exam, I will not give you this sort of, but I got confused. Like I have noticed that some of you are like got confused with the number. It looks like something big positive number. Actually, it is very close to 0. And now, since I said it is 0, almost 0, what is the next step? p-value greater than alpha, less than alpha. So if this value is 0, can we say 0? P-value 0 is greater than or less than? It's less than alpha, 0.05. So H naught must go. So H naught must go. What is H naught? There is no relationship. So there is a H naught must go means we found the support, we found the claim for the alternative. That means there is a significant relationship between X and Y. We did the same thing with the CI interval as well. And see that value, that conclusion and this conclusion, both are same, because both are the finding from the same regression line. So it has to be consistent. And that's what we are getting, but the different ways of making the justification, providing the justification. So in case of the regression line or the model is reliable or not, you need to look at not the CI interval, you need to look at significance F level, the P value. And then on that basis, you have to make the decision regarding H naught accept or H naught not accept. H naught, what is H naught? There is no relationship. Whereas H alternative is there is a relationship. So if H naught must go, means there is a support for alternative. That means there is a significant reliable relationship between X and Y. So the question is this a very valid prediction? Yes, this one is a valid prediction. This model is a valid prediction. This model is reliable because the significant F value is less than alpha, that is 0.05. So H naught must go. So we found the support for a reliable relationship, valid relationship between X and Y. So we can say this value, the 6.95 is a valid conclusion, or Y or X is a valid predictor for Y. So you have to build right on those lines. Yeah, please. I heard some voice. Please
Yeah,
go ahead.
sir. So is alpha always 0.05, or we just follow whatever is given in the sheet? Like for example, if it's point like 99%, then alpha is 0.01. We just follow the sheet.
You have to look at in the, fortunately or unfortunately, all the four examples I could see that it's a 95%, lower 95 or upper 95. But
Oh,
think about if it is a lower 99 and upper 99, then how much will be the alpha?
0.01.
Exactly. You need to be careful. Or maybe upper 90% and lower 90%, then
0.1.
0.1. So
Okay.
because it is 95 here, I have noticed that in the lower NCI. That's why I'm going ahead with the 0.05. Otherwise, not.
Okay.
So we have seen two different ways of, making, predicting some validity, or making something reliable, some kind of thing. But there is another way. I mean, there is a third way to do that, and that is residual plot. That is known as residual plot. So the last part I, based on the residual plot, is the regression equation a good model for the sample data or not? Explain why or why not. So this is the third way we are trying to see. And remember, all these are the different ways. As a researcher, if you report based on only one way, or using only one tool, probably somebody will doubt, like, no, maybe this may fail in other parameters, or using other techniques or another tools. That's why as a researcher, whenever I'm doing my PhD research and I'm trying to validate, is there a relationship between competition in CSR and from performance, I'm trying to bring it from the different lenses. I mean, to the different tools, different sort of analysis. I'm trying to validate the same finding again and again and again, in order to make my, in order to show, or in order to project my findings more robust. Why we do multiple times this reliability check using the different method? Because we wanted to have a strong claim for my research. That is only the idea. So any combination, maybe 2, 3, or 10 combination of tools you can use just to support a single relationship. Then everybody will say, okay, fine, 100% reliable. You're fine. So this is just like claiming again and again that this is a valid and reliable model kind of thing. So third way is using the residual plot. It won't be a part of your exam because I haven't say provided you this plot in the exam, but I wanted you to just have a focus on it. But before that, maybe I can go through the slide where we actually talk about residual plot. I will suggest you not to go in the technical aspects of this, how to plot. If you have time, you can do it. It's not a kind of big thing. I mean to say, it's it's very clear. Like you have to plot x and y. So you have to keep x as a x, but instead of y, you have to put y minus y hat. Y hat is your observed value. Using whatever you will get using the regression line, that will be y hat. And y is the value which is given. Like 2, 2. If suppose one point is given 2, comma 2. So in that case, y is 2, x is 2. But y hat you will calculate using the regression line. So if you do that, you'll get the regression plot. And there are 3 different plots here, which says that the plot 1, the figure 1 is the good model. Figure 2 and figure 3 are not the good models. The reason has been given here. Why the first one is a good plot? Because the residual plot suggesting that the regression equation is a good model because you could see the residuals. Residuals, what is residuals? Y minus y hat. This difference between y value and the observed y value using the regression line. That difference is known as residuals. So all the residuals we try to plot on the x-axis, vertical axis. So you see the residuals in the first case, somehow it gives you kind of impression. Just try to observe. Most of the lines, most of the residuals are equally distributed, not almost 100%, but somehow equally distributed above and below the horizontal line. So just as an observation, I could say, okay, it seems like it's a good model. But in the case of second image, you see the second figure, only 3 or 4 points are above the horizontal line, whereas 6 or 7 are at the below. Apart from that, we have noticed certain patterns. It seems like a kind of inverted U pattern of the residuals, like decreasing, increasing for height, and then again started decreasing. Something inverted U sort of pattern, or maybe the U sort of pattern. It should not display any pattern. So the residual plots in the second case is with an obvious pattern, suggesting that the regression equation is not a good model. In the part, in the figure third, residual plots that becomes thicker, suggesting that it is not a good model. So initially we saw that some of the residuals are there on the horizontal line itself, 1, 2, 3, 4 points. 4 residuals are on the horizontal line, but the remaining has to be again equally, you know, equally kind of a scattering. It should scatter, but over here, it is again some sort of pattern. Kind of you see it's a kind of becoming thicker in one direction. It's a kind of Y kind of. So since some patterns are coming out, we can say that it's not a good model. In order to have more and more analysis on these patterns, probably this is not the right time, but later on you can explore more and more. There could be a kind of 10 different patterns where it suggests it is not a good model, but only 1 or 2 where it suggests good model. So with that note, look at here. We have a residual plots for this one. And think about, do you think this is like, yes, 1, 1, 1, 1, 1, 1, then 2 points down and somehow 2 points. Not 100%, but it appears to me as well, right? That it seems, okay, based on the residual plot, is the regression equation is a good model for the sample? Yes. It seems like it's a good model for the sample data. Explain why or why not. Because the residuals are, reason I'm not saying why, because the residuals are evenly distributed above and below the horizontal line, and it is not displaying any specific pattern, particular pattern. So we can say the regression equation is a good model for the sample data. Make sense? Does that make sense to you?
Yes.
So don't worry, don't stretch yourself much regarding the residual plots, and this won't be a part of, in your exam as well. But understanding is important. You understood? That is good thing. So I can't believe just taking you for a simple exercise, it took 1 hour, 10 minutes. But I think doing multiple things in comparison to doing one thing in a right way and in-depth way, and doing slow with the slow pace, so that every one of you can understand what I'm trying to communicate. I think that is more important here. Instead of giving you heavy doses, it has to be kind of moderate level of analysis. Maybe we can do it quickly with the exercise number 4. Quickly, very quickly. So this one is exercise number 4. Do it quickly. Maybe I will leave the scattered plot, and I will just try to have a kind of regression one. Over here, again, the question is which one is X and which one is Y. Look at the output. In the output sheet, the right arm, they have kept it in the regression statistics. So what I said, whatever is there in the regression output, that variable is independent variable, and that is X. So over here, right arm is X. So for the X range, I'm writing right arm. Then for the Y, the other one will become, so left arm will be Y. I'm just following because the output is in such a way. Otherwise, we will have a different output. I'm just trying to match with what is given to you here. Other criteria will be same. I want you to see the output here. Okay. Simply, you see, by the simple observation from the residual plot, can you make assumption is a good model or bad model? Anyone quickly?
Good model.
What?
Good.
It's a good model basis on the residual plot.
Oh, maybe not, because there's only one that's like above the line.
Exactly. And see, the 4 residuals are at the down. So see the benefit. If you have very less time to conclude something, just quickly go through the residual plot and say line is not a good model. And since overall all your observation, all your findings has to be consistent, you will see the same result when you will look at the significant F level, or maybe when the confidence interval estimation. And we'll see that. Quickly we can go through that one. Okay. Exercise number 4. Quickly I will go through because speaking much make me tired. Turning myself in a bit tired. But anyway, I will cover this one quickly, and then probably I will give emphasis on the part E. Okay, let's go through that. What is the linear correlation coefficient R. R is 0.86. So 0.86 is in the range of 0.8 to 1.0. So we can say there is a strong relationship. You see the way I'm writing the answer? Since the multiple R equal to 0.86, it lies in the range between zero point 0.8 to 1.0. We can say there is a strong relationship between right arm and left arm. I'm not using the word X and Y. Try to adopt it to the great extent. Next, what is the regression line equation for the simple data? So the regression line will be right arm is your independent. So the next one, the remaining, which one will be the left independent one? It will be left arm. So you will write left arm, just writing left arm equal to constant V naught 43.56456. Again, the sign is positive here for the slope, right arm, plus slope 1.314. So make it 3.31. And then, can we write X? No. See the variable, it is a right arm. So you will write right arm. You will get 100 marks for this one. This is the right equation. What is your interpretation for the slope? Every unit rise in the right arm, left arm will increase by 1.31 units. Full stop. That is the interpretation. What is the 95% confidence interval for the slope parameter? Again, where is the slope? Over here. This is the slope, right arm. So what is the interval here? These two. Want to see, make it more closer. Let's see here. What interval you get? This is the interval where the slope lies, minus 0.7 to 2.7. I mean to say slope could be 0 as well. There are chances at 95% confidence level, there are chances that slope could be 0 as well because it lies minus 0.7 to 2.7. So the interpretation over here, based on that, is there a linear relationship between X and Y? Since 0 lies between this interval, we should not reject null hypothesis. That says null hypothesis is there is no relationship. So we can say, is there linear relationship between X and Y? There is no linear relationship between X and Y on the basis of confidence interval estimation. Is that answer is matching with the residual plot? Yes. We said in the residual plot, this is not a good model. Just observing. Just with the observation, we said that. One point is above and 4 residuals are below. It's not equally distributed, not 100%, but to a great extent it's not. And that's what we are getting in the CI interval also, saying that no, this model is not. Next one. What is the value of determination of coefficient of determination? In this case, R square is 0.7518. So the 75.18% variance in Y? No. 75.18% variance in left arm is explained by explanatory variable right arm. So did you notice that x and y we were using in the last example, but over here instead of x and y we have different variables, left arm and right arm. So you need to write clearly your argument, your answer has to be in terms of left and right, but it should not be in opposite way around. You should not use the right arm instead of left arm or left arm instead of right arm. So variance in y is left arm. See the equation, regression equation. Which one is the dependent variable? Left arm. So 75.1% variance in left arm is explained by predicting variable right arm. What do you think? Is it a strong predictor? It's a moderate predictor? It's a low predictor? Or there is no relationship, no prediction? There is a prediction because multiple R is there. But what sort of prediction is this? On the basis of R square? 0.75, it's maybe the moderate level, in between 0.5 to 0.8. It's a moderate level. So we can say the right arm could be moderate level of predictor for the left arm. But we are not talking about the reliability or validity. No, we are not talking. But it could be. Right arm could be moderate predictor for the left arm. Full stop. Part H. What is the predicted y if x equal to 5.5? So where? Wait. I don't know. I think there is a. Just hang on. Okay. Exercise. A, B, C, D, E, F. Where is that F? Question F. Okay, over here. So is based on this interval we have seen, okay, coefficient of determination ho gaya. Okay. What is the predicted blood pressure in the left arm if the blood pressure in the right arm is 100 mm per G per Hg? Hg is probably para. What is that? Hg is a chemical name for what? Any guess? Did you read chemistry? Hg is for what is there in the thermometer?
Mercury.
Mercury. Thank you so much.
Yeah.
Yeah, Hg is mercury. I was trying to recall it, but thank you so much. You did it before me. Thank you. So yeah, so 100 mm per Hg. So the value is given for right arm. So see the equation. If you put the equation 100 as a right arm, so 1.31 into 100, it will be 131 plus 43.56. That will be the answer of the left arm. But the question is this is a valid prediction? And for that, now you know what to do. You have to look at significant F value. It is clearly mentioned here, like no need to worry about in terms of, there is no nothing such as like exponential E or something like that. It's very clean. Probably in the exam, it will be clean like this. Now, since this is the P value, do you think this is a greater than, what is the alpha value? 95%.
Greater than.
Yes. So since P value is greater than alpha, so we should not reject the hypothesis. What is null hypothesis? There is no relationship, reliable relationship, valid relationship. There is a relationship, but it's not reliable. We can't be based on, our decisions will not be based on this model because this model is not reliable. That means the chances of error could be. So you should not go ahead with this prediction that this will lead to this, left arm will lead to that. This is not the valid prediction. That's why we saw the same finding across all three methods. Residual says not a good model. CI intervals clearly says that zero lies. So that means slope could be zero some point of time. So we are 95% confident that this is not reliable. Maybe it will be reliable at 99% or not. That is another story. But the question is 95%. No, it is not reliable. The same thing is coming out in the model. Regression model is reliable or not. Again, we saw that p-value is greater than alpha. So we should not reject null hypothesis. Means there is no reliable relationship between x and y. Although we have provided the value of left arm using the regression equation, but is that reliable? That means is that value will always appear? No, sometimes. Because sometimes the slope may be in the positive. It see 0.07 to 2.70. It includes 0, but it includes positive also, 0.01 till 2.7. So, but 95% we are not sure that this is reliable. This is the logical interpretation. It has to come in your mind. So is this is a valid prediction? No. The reason p-value greater than alpha. And then finally, part I, based on the residual plot, is the regression model is a good model for sample data? We have already gone through this one. No, this is not. I think I have covered exercise 3 and 4 in a nice way, and with lots of exercise, I believe that now with your journey towards your final term exam will be easier. As I said, around 60 to 70% will be covered from the week 8 to week 12, and maybe 20-25% will be from the back, from the initial units, and probably I will be covering those things in terms of MCQ, multiple choice question. Try to select the most appropriate answer in the multiple choice question, 10 questions. And probably if I could remember, you can think about again the probability, do some little bit exercise on the probability. You remember, like we had a formula of NCR, PQ, RQ or something like that, maybe some of you do some of the exercise on those ones. That will be fine, but not on a great scale. So we have last 25 minutes or 30 minutes, and I wanted you to let me know in case of any difficulty, maybe related to the study stuffs or maybe anything regarding the exams. I won't be there in the exam, so no need to worry. Just attempt at your best. It's a closed book, so only one page. Just keep it for the writing, doing some calculation. Otherwise, so I'm closing here, but I will be here for taking questions one by one. Those who wanted to leave can leave, but before that, make sure you have marked the attendance. Okay, since this is the last class, I must not say goodbye to everyone. I wanted you to, if you wish, you can get in touch with me anytime in your life. We are now in a student and teacher relationship. So if you wanted to have a kind of just suggestion for your journey in your education or maybe in your research throughout your life, I will suggest you to get in touch with me through the LinkedIn. Maybe not one of you aware of the LinkedIn, but you can open your account in the, it's a kind of it's more as a kind of professional platform. It's not a personal, but yeah, it's a very successful platform. LinkedIn, everybody now, you get connected with anyone around the world through this. It's a purely professional platform. So if you wish, you can get in touch with me on this anytime through this LinkedIn profile. And maybe, but before, in order to have that one, you need to have a kind of your own personal LinkedIn account. Then only you will be able to. I'm pasting here the LinkedIn profile of mine. Later on, you can wait to show you this one. Yeah. So I have shared you the link of my LinkedIn one, but in order to accept or invite me, or you need to have your own account, then only you'll be able to. It's just like this how social platform like Facebook and Twitter, how they work. You must have your own account, then only you will be able to send them. So you can get in touch with me through this LinkedIn profile. I will be I will be happy to see you all guys, you all growing in your life, reaching new milestones in your life. I will be really happy to see you guys like doing good in your life. And whenever, as a like teacher, as a friend, or as a mentor, whenever you think you need, whenever you feel like for any assistance, I will be happy to help you. That is not a problem. That is my promise actually. So it's entirely up to you. So now I'm closing this session, but I will be here for another half an hour for one-to-one questions discussion. I'm stopping the recording as well.